Okay, so on Wednesday I began working through chapter 12. And what I'll do for you all today, since you haven't had a chance to see that video yet, is I'll give a brief overview of what I covered on Wednesday, and then we'll have some time to finish the material from chapter 12, and then I hope to work into some algebra, and maybe work a couple of the practice problems from the end of the chapter to try to really solidify our understanding of this material. We've been working towards an understanding of the IS and LM curves, which develop a model where the market clears when the interest rate is allowed to fluctuate. So we have an IS curve, which is like a demand curve, but it's not really a demand curve. It's the representation of how we come to equilibrium in the goods and services market. So this is about goods primarily. The IS curve is familiar because it comes from the equation where Y equals a function of consumption as related to total output minus taxes plus the relationship of the interest rate plus government spending. Now, when we're developing an IS curve on these axes, we can only allow R and Y to vary. So that R is going to be here and Y is here, and we have to hold T and G constant because they are exogenous to this graph. They're not on the axes. If G, government spending, were to change, it would shift the curve. But if the interest rate or output changes, we move along the curve. So again, the difference between exogenous and endogenous variables is relevant here. So we're put a little bar over the G and the T to remind ourselves that we're only really letting that those would cause a shift in the whole curve. Okay. Then we also have the LM curve. LM has to do with the liquidity preference for money, or the money market equilibrium. And in that equation was LM is M over P equals some function of Y and I, or we could call I R, I suppose. Y and R, the real interest rate. And again, thinking about which variables are endogenous or exogenous, right? We have Y and R on the graph, so those can vary, but M and P have to be held constant, otherwise they cause the LM curve to shift. And unusual for economics, we're going to talk about the LM curve as shifting up and down rather than left and right. Usually we talk about curves shifting left and right. So if the quantity of money increases, we don't move along our LM curve. If the quantity of money increases, how would that affect this graph? A higher M should be met with a higher Y and a lower R. So if M goes up, the LM curve shifts like this. Right? And that would be consistent with a higher Y and a lower R. in equilibrium. Okay, so we have our endogenous and our exogenous elements. The reason we build this model is because altogether these components contribute to our aggregate demand in the macroeconomy. That goes back to our aggregate demand, aggregate supply curve that you'll remember from intro to macro. And what's different between this graph and our aggregate demand graph is that, yeah, we still have output on the x-axis, but here we have the price level, or changes in the overall price level. So we're building here this component of our aggregate demand graph. Well, remember that our long-run aggregate supply curve is vertical. That signifies a constant level of output. Well, since long-run aggregate supply is vertical, for any level of output, price isn't affected. That output remains the same. Well, it turns out that for that reason, we can put the long-run aggregate supply curve on this graph as well. Long-run aggregate supply is not affected by the interest rate either. In other words, long-run aggregate supply is about how much stuff we can actually make. It's more about how far out we are on the possible production possibility frontiers, where we are in terms of our overall level of productivity. And if we're on our frontier, then we're home, we're doing as well as we can. If we're too far beyond or too far beneath, then for some reason our long-run aggregate supply curve is no longer in equilibrium with our LM and our IS, nor is it in equilibrium either in the long run or the short run with aggregate supply. So the trick to the process here then is to think through how changes in the variables that are being held constant when we set up the model bring about changes in our ISLM framework, and then how that feeds into changes in aggregate demand, bringing it into equilibrium or out of equilibrium. For example, I did that part of the mistake. Suppose that a housing market crash reduces consumers' wealth. So this is how we play the game from here on out. And it's similar to the way we played the game with our basic supply and demand graphs. We would set things up and say, you know, it was a dark and stormy night that day at the party, all was quiet. One who came to sell something found someone to buy it. And then suddenly, some exogenous thing shocks the market. This morning, with my intro students, I said, what happens in the market for commercial aircraft manufacturing when there are greater profits to be earned making energy drinks? And the correct response was, well, some of the firms that are producing aircraft would switch to making energy drinks so they could earn those higher profits. Now, that's not what actually would happen. Funding for the production of aircraft would be taken away because there's no more investment, and that investment would instead flow into the making of energy drinks until profits in both industries were equilibrated, right? But as far as our view of the market goes, that exogenous shock has nothing to do with aircraft. Energy drinks, what? It causes a shift, a leftward shift of the supply curve for making aircraft, pushing the price of aircraft up, reducing the quantity, which it would in turn increase the profits earned by the average aircraft manufacturer until they do come into equilibrium with the production of energy drinks, right? So this kind of exogenous approach. And so we'll say, okay, in this world, what happens if the housing market tanks? So you try. The housing market tanks. How does that affect either the IS curve or the LM curve? Well, a lot of people treat their houses like piggy banks. So they store up wealth in their houses in the same way that other people, or sometimes the same people, store up wealth in the stock market. So if the housing market tanks and you've been pouring money into your house, paying your house off, getting a second mortgage, fixing up your house, all of your wealth is tied up in your house, but then the value of your house collapses, which of these variables is that going to affect? Yes, consumption. How? Well, in a way, it affects your permanent income. Right, so this came up on the exam. Right? That if your housing becomes less valuable and you're practicing permanent income, then your consumption today will decline to make up for that decrease in lifetime wealth. Okay, so then as this declines, right, overall consumption is going to decline. How does that feed in? Well, if this gets smaller, if this term gets smaller, then how will we show that on our graph? I think we show it by decreasing the IS curve. And what then? So consumption falls due to lower wealth and lower income. Now this as a result brings about a lower interest rate and lower income. But what does a lower interest rate do? Increases investment. Good. Okay, and that's in this term, isn't it? So then the decrease that would be represented by a complete change, this entire distance of the IS curve is mitigated somewhat by the fact that there's a feedback mechanism through investment that increases investment when consumption is decreasing. What about unemployment? What happens in terms of employment or unemployment? It's not in the model, right? Evidently, but what do you intuit?
Unemployment increase.
Unemployment increases, and that's basically represented by Y as well, by the shift in Y. Okay, Y is total output. If a total output or total consumption decreases, well, it must be that there's less employment going into making stuff. Okay. Right. The textbook does a long discussion of the Great Depression in chapter 12. I'm going to save that for next week. The next step in this analysis is to say, okay, how does IS and LM come into interaction with aggregate demand? And when there is a shift in the IS curve, here it goes to the left, then and we're just going to look only at aggregate demand for the moment, right? Then that would be accompanied by a leftward shift in aggregate demand for any given price level. right? Suppose we hold price constant, then output is going to shift in the same way that this is shifting. Now that is if we hold the price level constant. So we're primarily going to read off of the y-axis from the ISLM diagram to the aggregate supply, aggregate demand diagram, and shift our curve relative to what happens with the variable y. So if the Fed wants to increase aggregate demand, in a separate example, suppose the Fed wanted to increase aggregate demand and cause it to shift to the right. How could it do that? This you should remember from the intro, but we're going to see how it works through the model. To increase aggregate demand through monetary policy would be a shift of the money preferences curve. And the way they would do that is by increasing the quantity supplied of money. So by increasing the quantity supplied of money, that causes a shift downward of the LM curve, which results in a rightward shift of output, which evidences itself in a rightward shift of the aggregate demand curve. Why? Because I haven't done anything to prices. Prices have been held constant here. And so for any given price, the output will have changed. Now the next thing to think about here is, well, that works in the short run. And in the short run, from a Keynesian perspective, in the short run, prices are sticky. So from the Keynesian point of view, prices are sticky in the short run. So every time we take some sort of a policy action that affects IS or LM, in the short run, we're going to assume that the price level is being held constant and the entire change in output goes only into a leftward or rightward shift of the aggregate demand curve. Notice also that nothing here is involved in the aggregate supply curve. None of this is in the aggregate supply curve. If prices are sticky, aggregate supply is flat. If prices are flexible, then perfectly flexible, then aggregate supply is perfectly straight up and down. And it's the basic monetary point of view. So suppose that initially we're in a world where, for whatever reason, so in the short run we have our IS curve, we have our LM curve. Let's suppose for whatever reason we're not in an equilibrium that produces full output. We are for some reason away from our long run aggregate supply curve. If this were the case, then we could also say that because price is being held constant, that we're in a place like this. That shows up over here like this, where output is not at its full potential. Okay, then how do different approaches think about this? If in the short run this is the scenario we're in, then there's nothing that can be done about it because prices are not flexible, at least not from the point of view of monetary processes in the short run. We could increase the quantity supply of money. If we increase the quantity supply of money, then what happens is that we bring LM down, and bringing LM down shifts aggregate demand to the right, and we could end up at a new equilibrium where we are back on the long run aggregate supply curve. That would be an interventionist monetary approach. That would be a Keynesian monetarist approach. This is most commonly affiliated with Milton Friedman. A Keynesian approach, instead of interacting somehow through the monetary side, would seek to instead affect aggregate demand by influencing the IS curve, either by reducing taxes or increasing government spending. Either approach, a reduction of taxes or an increasing government spending, would have the consequence of shifting to the right the IS curve. Shifting to the right the IS curve shows up on the overall market for goods and services here as a rightward shift of aggregate demand that could bring us back to equilibrium. Both approaches do the same thing in terms of shifting the aggregate demand curve. The classical model would instead say, instead of intervening through changes in money, changes in taxes, or changes in government, it would say the only other variable that can change here, that could cause a shift, is a change in prices. And how could we get a change in prices? That would take a long time, but the classical model says it'll happen. If we're out of equilibrium for whatever reason, then what we ought to expect over the long run is a decrease in the level of prices. A decrease in the level of prices will have the same effect as a rightward shift of the LM curve, in the same way that an increase in the quantity of money would if we tried to do it in an interventionist way. So a decrease in prices eventually would result in the shift of the LM curve in the same way that we would do so in a way that causes prices to fall. So instead we would move along our aggregate demand curve in order to get there. So the classical approach says prices can change. The Keynesian framework says in the short run at least, prices cannot change. The next thing that we can do then is something really kind of complex and a little bit tedious. Hopefully it pays off. Let me give it a shot here. But we understand now how our ISLM feeds into our aggregate demand curve. We have different attitudes or approaches about the stickiness of prices feed through this mechanism. Let's see if we can gain any intuition about how these variables are working together. Instead of doing it geometrically, doing it algebraically. Let's see if we can do this. Now, if we think about the IS curve, we've said that it is the concept that y equals c of y minus t plus I r plus g. Let's say that, let's try to make this a little more concrete and say that c of y minus t, this function, has this actual expression, a plus b times y minus t. So what are a and b? They're just some number. They're just some number that we can plug in here. This reminds us of the consumption function that we talked about earlier in the semester, where there is an intercept, which would be a, and then there's a slope, which would be B. Okay? And what we're going to do is we're going to walk through several steps of this and think about what these variables are holding the place for, and see if we can gain any intuition about the direction that things change. So we also are going to need an explicit algebraic expression for investment if we're going to go any farther with this. So then we say for this function, we're going to say that that can be expressed as C minus dr. So if you remember, if we have the interest rate and we have the quantity of funds being invested, as the interest rate falls, the quantity of funds that get invested increase, so this has a downward sloping relationship. That is evidenced by the negative sign at this point in this algebraic expression. The C, again, would be the intercept of this relationship, and D would be the slope of this line. What happens if I take these pieces and plug them into this and try to work it out? So I can say that y is equal to a plus b times y minus t. This is taking the place of this, plus c minus dr plus g. Okay? Now I've linearized this whole thing. What happens if I solve for y? Because right now I've got two y's in here. What happens if I solve this whole thing for y? First I would have to move this chunk over here, right? Do I want to do it that way? Let me distribute the b first. So y equals a plus by minus bt plus little c minus dr plus g. Remember that this has nothing to do with consumption, okay? Then I want to subtract by, so y minus by equals a minus bt plus c minus dr plus g. I can take this and say that this is equal to, factor out the y, 1 minus b is equal to all this stuff again. Now I can rearrange this stuff. I don't see a big value in rearranging it right now, but I'll just do it because it walks it through this way. You can say this is equal to a plus c, so I've got this, plus g, I've got this, minus bt, I've got this, minus dr. Okay. No big deal about rearranging that stuff. To get y by itself, though, I have to multiply both sides by 1 over 1 minus b. And that'll get rid of this term. And what I'm left with is y equals 1 over 1 minus b times a plus c plus g minus bt, capital T, minus dr. And this is what we're looking at. This equation confirms that the IS curve does indeed slope downwards. Why does it do that? How can we tell that it does that? Because here y is positive, and here the sign on r is negative. So the IS curve has to slope downwards. This term has to do with government services multiplier, or the government purchases multiplier. So it explains to us how much Y changes for a given change in G. If we have an increase in government spending, right, if we have an increase in government spending but nothing else changes, if taxes are held the same and the interest rate is held the same, if the slope of consumption is held the same, if the slope of the interest rate is the same, okay, if everything else is held the same and there's an increase in government purchases, how will that affect total output? Well, we have to multiply that by this term, and we'll find that any change in government spending is multiplied. Because if B is some number less than 1, as we define it to be, the marginal propensity to consume is less than 1, then this whole term, 1 divided by 1 by minus some number that is less than 1, this number is larger than 1 as a result. So then, however much government gets spent, it gets multiplied by this, and that is how much it affects output. So the algebra of walking through this, the goal of it is to say, okay, well, I can ignore this and this and this and this and this and this when making some sort of an analysis on this and see that a change in this affects this by this much. And that's why we do it that way. Now, when running an empirical analysis of something like this, right, getting the statistics, you'd have numbers for all of these placeholders, and the goal would be to find probably the elasticity between this variable and this variable. And then you'd be able to report that and say, okay, this is how these two are related. This is how much this is going to affect that. So that was so much fun that we're going to do it again. We're doing time, plenty of time actually. This time for the LM curve, which is a little bit simpler. Now we understood that the LM curve was represented by M over P being equal to some function of R and Y. So then, in order to linearize this in any kind of way, we would have to give some actual algebraic expression for that function. So let's give it some sort of a generic algebraic function. We can say that L Ry is defined as E of Y minus F of R. Again, why should it be this way? Because notice there's a downward sloping element between output and R. Is that right? Let's see what happens when we plug it back into this. So we end up with M over P equals E Y minus F R. And we can solve this for R. And playing with the algebra here, to solve for R, we get M over P minus E Y equals negative F R. So then I can multiply everything by negative 1, switch sides. F R is equal to E Y minus M P. And then R would be equal to E over F times Y minus 1 over F times M over P. And how would we interpret this expression? This confirms that the LM curve slopes upwards. Why does it do that? Well, we've got a positive sign on R, and then the coefficient related to Y is also positive. So as income goes up, we move along the LM curve upwards. So then that generates the outcome that the LM curve is in fact positively sloped. Alright, well, I'm changing this to a graph about output now. What else can we see? Well, if the quantity of money goes up, then that feeds through a negative element, which causes a decrease in the interest rate. So if the quantity of money increases, we're going to shift our LM curve down. If the price level goes up, well then that actually makes this variable smaller, and taking away a smaller number causes this number to go up. So if the price level goes up, it causes the LM curve to go up. So walking through an algebraic example of this, hopefully it adds an element of intuition to all of this. The final step in doing all this would be to build the entire aggregate demand curve. So to build the entire aggregate demand curve, we would want to wash out the interest rate, because on the aggregate demand curve, the interest rate isn't involved. Instead, we put the price level on the y-axis for that. The easiest way to do that would be to take R here, what we've solved for R here, and plug it in for R here. So we could just drop it in right there. I'm going to rewrite it up here. I'm going to drop this in that R. And what I get is that y equals, I'm going to drop it in for this R rather, over here. Y equals 1 over y minus b, open quantities, A plus C plus G minus B T close minus D times E over F from over here times Y minus 1 over F times M over P, and that is a monster of an equation. And notice I reintroduced another y back into it. So to solve this completely, I'd have to get that y all by itself again. So I'd have to bring this y over here with all of these other hangings-ons and then solve for y by itself again. I'm going to skip a step, and those algebraic nerds that want to can work it through. I'll show the outcome. When you work this through, this is what I hate the most about what a professor will sometimes do. It's not show the actual algebra, but I want to get to the intuition here. Is this even useful? This is an expression of our aggregate demand curve. Why? Why is that true? Because we have in here a whole bunch of little letters that really are just holding the place of things. So this is just holding something's place. Each of these terms is holding the place of something. This is holding places, this is holding a place, this is holding a place, this is holding a place, this and this and this and this. But I have y in terms of p, m, and g remaining. And those are the interesting variables that are left over here. Notice here we had, let's do this one. Here we had y in terms of g. This should be a capital T. That's also an interesting variable. T and r. In this story, when government increased by a certain amount, it increased output by this much. In this story, when government increases by the same amount as what it increases here, it feeds through this instead of this. This term has the same stuff in it as this term, plus a bunch of other stuff. This term makes the denominator of this term, relative to this term, bigger. When the denominator of this term is, or at least, sorry, this portion of the denominator is bigger, right? It means that the multiplier is less effective on the aggregate demand curve than it is on the IS curve. We see that the relationship between output and price is indeed inversely related. Price is in the denominator here. So as price gets bigger, y gets smaller. So we affirm the negative relationship, or the inverse relationship between price and output. We see that an increase in M increases Y, especially if P is held constant. So that means that if there is an increase in Y, it brings about a rightward shift of the aggregate demand curve. An increase in government spending increases the aggregate demand curve. There's a negative sign here, so an increase in taxes shifts the aggregate demand curve to the left. And what this is called about, because the denominator of this term is different from the denominator of this term, we call that the crowding out effect. The short run crowding out effect. You see, an increase of spending in the ISLM model is smaller as a result. What we can take away from something like this is an appreciation for the complication required in doing empirical analysis on these kinds of things. That the equations are complex. Now, if you were to go and read some journal articles in economics, it gets way more crazy than this. Not always. It doesn't necessarily have to, but in order to build a very precise model that can be tested with data, you end up having to walk through a lot of algebraic craziness like this to go ahead and run your regressions.